Every large language model judge has a blind spot. Ask it to score an answer and it picks one perspective, a single viewpoint, and quietly ignores everything outside it. A user cares about usefulness, a domain expert about correctness, an educator about clarity. One voice cannot recover all of them. The result is what the authors called dimensional blind spots, answers that game the rubric, and judging accuracy that swings with the domain. A team from Lightspeed and CU Education Shenzhen found a fix. Don't train anything. Just ask the model to wear 5 hats. The method is called multi-role rubric generation. It is training-free and reference-free. One model is instructed to adopt 5 complementary roles: user, domain expert, educator, AI researcher, and linguist. Each role emits a compact rubric of atomic yes or no criteria with a self-assessed importance weight of 3, 2, or 1. The 5 rubrics are concatenated and deduplicated. But here is the key design choice. They remove only exact text matches. They deliberately do not semantically merge. If 3 roles independently flag the same idea, that agreement is itself a signal of importance, and merging would erase it. The result is one score between 0 and 1, usable unchanged as a judge or as a GRPO reward. The evaluation is thorough. 5 backbones, Qwen 2.5 at 3, 7, and 32 billion, plus GPT OSS at 20 and 120 billion. 3 benchmarks, Reward Bench 2, Judge Bench, and PPE. For reinforcement learning, they take Qwen 2.53 billion instruct, run GRPO on 2000 wildchat prompts, generate rubrics with GPT 4.0, and judge each criterion with GPT OSS 120B. Then they test the downstream policy on ByGG Bench and Health Bench Hard, the latter 1,000 examples where many frontier models score 0. Why exact match dedup instead of an LLM consolidation step? 2 reasons. First, consolidation adds another bias judgment, deciding which criteria are redundant or conflicting, and that bias propagates. Second, and more interesting, when independent roles independently emphasize the same criterion, that convergence is evidence the criterion matters. Collapsing it throws away a signal. The authors tested this directly. A variant that adds an LLM merging step, called MRRGC, loses 5 to 13 points. Keeping the mess beats cleaning it up. The cleanest evidence is an ablation. A single row alone, even the best one, educator, scores 37.8 on Reward Bench 2, trailing the full 5-role rubric by 13 points. Now the subtle part. They repeated single voice generation 5 times to match the call budget, then applied the same post-processing. That reaches 43.9, still 7 points behind, so the win is not more criteria. It is genuine role diversity. 5 distinct perspectives beat 5 copies of 1. Does it survive as a real training reward? Yes. Used as the GRPO reward for Qwen 2.53 billion, it lifts Health Bench Hard from 28.7 to 32.1, beating every rubric baseline. ByGG Bench rises from 62 to 63.7. The Health Bench margin is about twice the ByGG margin, evidence that multi-role rewards generalize better under distribution shift. And it works at scale. Across 5 backbones and 3 benchmarks, 15 cells in total, multi-role rubric generation is the best method on everyone. The gain over the strongest baseline ranges from 3.1 to 16.4 percentage points. GPT OSS 120B jumps from 52 to 74 on Reward Bench 2. 1 narrow voice leaves blind spots. 5 complementary voices cover the space, on a scope. First, gains shrink as the backbone gets stronger. Qwen 3 billion improves by 11 to 14 points, GPT OSS 120B by only 3 to 10. The multi-role prior matters most where the single evaluator is weakest. Second, the reinforcement learning win is an average, not a sweep. Multi-role is not the best on instruction following, planning, accuracy, or completeness. Third, the 5 roles are hand-designed, and the claim that no single role is critical rests on figure reads, not a verbatim table. Many voices, 1 reward. Decompose an opaque quality score into verifiable criteria, elicit them from 5 perspectives, deduplicate by exact match, and you get a training-free judge that also works as a reinforcement learning reward. Subscribe for the next paper breakdown.